everybody. In this video, we are going to be talking about solving one-step and multi-step inequalities, which is unit, 10.2.1 and 10.2.2. Just real quick, inequalities are similar yet also different to equations. So our solving process will still be really similar to what we did for solving equations. There was going to be one little step that it will change just a little bit, and we're going to talk about that in today's video. And then the other thing I just really want to point out is that when we're talking about inequalities, our answers or our solution set will actually be a range of answers, or it's going to start at one point and it's going to extend infinitely in one direction. Versus when we're solving for equations, we typically only come out with a single answer. And that's for most cases. And definitely all the cases that we looked at. So anyway, with that little bit of introduction, let's get started. And this first paragraph just kind of talks about what I just introduced to you as well. So sometimes there is a continuous range of possible values to describe a situation rather than a single answer. So the single answer is, again, typically our equations that we've been solving, and the continuous range is going to be for inequalities. In that case, inequalities can be used to represent the situation rather than equations. An inequality is a mathematical statement that compares, for example, two expressions using an inequality sign. In an inequality, one expression of the inequality can be greater or less than the other expression. Special symbols are used in these statements. The box below is going to show those symbols. It's going to give you the meaning and give you an example for each of those inequality signs. So the first one is an x does not equal y. So x is not equal to y. And an example of that would be the number of days in a week is not equal to 9. So maybe the number of days in a week, which would be 7, does not equal 9. The next inequality symbol we're going to talk about is x is greater than. X is greater than y. And again, don't forget, you can either read that symbol from left to right, and you're saying, like here, if we're reading it from left to right, the inequality sign, it's larger. The larger piece is opening up to the x. So x is greater than y. Some of you have talked with me about how your teacher way back when would talk about how the alligator eats the larger value. I've mentioned before that my kids, they are now drawing like Pac-Man symbols. They're going like this. And so x is greater than y. Whatever works, whatever helps you remember. Okay, so example, the number of days in a month is greater than the number of days in a week. The inequality, this next little part is going to talk about, well, how we can flip-flop it. So we absolutely can. Like we can say x is greater than y, but we can also flip it and we can start with the y instead. But if we start with the y instead, we also, guess what? We needed to flip the sign. So you notice here it's greater than, but here it's less than. And then look at y. Why did that change? Because look at what side of that inequality symbol is pointing towards the y. Like what is the y? If you read it from this direction, if we read from right to left, it would be y is less than x, which is exactly, if we read it this way, y is less than x if we go that direction. So anytime you flip-flop your numbers or your variables on either side of the inequality symbol, you also have to flip your inequality symbol for it to still be a true statement. And that's what we're getting ready to write in here. The sides of any inequality can be switched as long as the inequality symbol between them is also reversed. All right, so our next one we're going to talk about is x is less than y. The number of days in a week is less than the number of days in a year. All right, let's look at our next one. The next one should be x is greater than or equal to y. X is greater than or equal to y. So our example, 31 is greater than or equal to the number of days in a month. So 31 is greater than or equal to the number of days in a month. And then lastly, we're going to have x is less than or equal to y. X is less than or equal to y. So an example, the speed of a car driving legally in a 25-mile-per-hour zone is less than or equal to 25 miles per hour. All right, so our next paragraph, we are going to be talking about how do we graph these things, because we are going to graph our inequalities on a number line. So solution sets to inequalities can also be represented on a number line. So first, let's take a look at the symbols we will use on those number lines. Each of these graphs begins with a circle, either an open or closed circle, which is shaded in. So for example, it's either going to be an open circle or a closed circle that we'll start with. Well, how do we know where to put it? Well, it's our end point, or it's what's called our critical value of our solution. And so that's what we're going to fill in next. This point is often called the end point of the solution. And I want you guys writing this in too, because this is what I tend to refer to it as. The endpoint, we call it the critical value. Because it is so critical, right? It is your critical, and that's just by definition. It is called your critical value or your endpoint of your solution. So for example, like if we had x is greater than or equal to 3, the 3 is considered your endpoint or your critical value. A closed or shaded circle, so this is important for you to kind of keep track of this. A closed or shaded circle is used to represent what are called weak inequalities, which are greater than or equal to. And then we're going to fill in what that symbol looks like. So a greater than or equal to looks like this, greater than or equal to, or less than or equal to. And we're going to fill in what that symbol looks like. And those types of inequalities, whether it's greater than or equal to or less than or equal to, those are considered weak inequalities. And on those graphs, they're going to be the closed in circles or the shaded in circles. And then the point is actually part of your solution set, which is why it's shaded, right? So the endpoint, and you might want to fill that in, the endpoint is part of our solution for that. An open circle, so this part you might want to highlight too. The open circle is used for strict inequalities. So there's weak versus strict, which are strictly greater than, and we're going to fill in what that symbol looks like, or less than. The point is not part of the solution. And I'm actually going to fill in the word end, the endpoint, which I also like to call the critical value is not part of the solution set, which is why it's an open circle. It's not included in our solution set. The graph then extends endlessly in one direction towards either positive infinity or negative infinity. And this is shown by a line with an arrow at the end. So we're going to do some more graphing of these on the next page, but I'm going to give you one example. I'm just going to give you two right here. So it's right here underneath your paragraph. So if we have our solution set of x is greater than or equal to 3, you're going to put your critical value right in the middle. So it's going to be 3. We're going to do an integer value on each side of it. So 2 and then 4. And then keep in mind, going to the left is going to get you to negative infinity. That's your symbol for infinity. So let me write that. So that's negative infinity. And then our positive infinity is going to be over here on the right-hand side. All right, so our critical value, look at this. Is it included? Yes, because it has that equal sign on the bottom, which means what I'm going to do is I'm going to put a circle. We start with a circle, and then you determine, is it open or a closed circle? It's a closed circle because it's greater than or equal to 3. That 3 is included in our solution set, so you fill it in. And then you look and you say, okay, all of my answers, all of my x's either have to be greater than 3 or equal to 3. So which way am I shading? I'm shading to the right to represent what my solution set is on my number line. So I'm shading to the right because it's anything, my answers, my x's are anything that are greater than 3 or less, or greater than 3 or equal to 3. So the equal to the 3 is the shaded in 3, and then shading to the right is anything that's greater than 3 towards positive infinity. All right, so we're going to do some more examples right here. So another one, let's say we get one and it's like x is, let's say, less than negative 2/3. Less than negative 2/3. So first, let's draw our number line. And then let's think about what two integer values negative 2/3 is in between. And it should be in between 0 and negative 1. So we're going to have 0 and negative 1. And then we're going to put negative 2/3 on there. And so just guesstimate. So here would be negative 1/3, negative 2/3. So I'm going to put negative 2/3, and I'm going to start with a circle, right? Start with a circle, and we're going to put negative 2/3 to represent that. And then you determine, is it an open circle or a closed circle? It's an open circle because this says all of my answers are less than negative 2/3. Is it equal to negative 2/3? No. So all of my solutions are going to be less than negative 2/3. And by the way, here's negative infinity on this side, and here's positive infinity on that side. So there's another way to graph those when it's less than and we have an open circle. And then let's try this one. If I've got x, nope, we're not going to start with x. Let me delete that for a second. We are this time, sorry, starting with negative 4, and it is greater than or equal to x. So that's the one we're going to start with. So first, what I'm going to do is I'm actually going to rewrite this so that my x is on the left-hand side. So I'm going to flip it. I'm going to do x and negative 4. And then don't forget, if I flip-flop them, what do I have to do with my sign? You've got to reverse it as well. And that was talked about, if you don't remember, that was talked about right here. And so we're going to come back. If I flip-flop it, that means look at what side was already showing or closest to the x, and it was x is less than or equal to negative 4. So now I'm going to draw my number line. I'm going to put negative 4 is already an integer value, so I'm going to put negative 4 here. What number would be to the left of it? It would be negative 5. What number would be to the right of it? It would be negative 3. And then is it an open or closed circle? It's including negative 4, so therefore it is a closed circle at negative 4. So I'm going to fill that in. And am I shading now to the left or to the right? Well, my solution set, all of my x's are less than or equal to -4, so I'm shading to the left on that, towards negative infinity, and here's positive infinity. And that's your answer for that. All right, so let's talk about our steps for solving multi-step inequalities and how they're different from equations. So we are going to use the same process solving inequalities as we do for solving equations, where we isolate the variable. So we are going to do the reverse order of PEMDAS, but using the inverse operation to undo the inequality. There is one very important new rule, though, for inequalities. Whenever you multiply or divide both sides of an inequality by a negative number, the inequality sign must be reversed in order to keep a true statement. However, if you add or subtract a negative number, the inequality stays the same. So let's just talk about examples regarding that really fast. So for example, if we have something like this, negative 2x is less than, we're just gonna make it easy, is less than 10. And then I say, okay, I need to solve for x. Well, what would we do if it was an equation? We would divide both sides by -2. And that, excuse me, that's exactly what we're gonna do here. We're gonna divide both sides by -2. When we do that, math sirens should be going off in your head, because when we multiply or divide both sides of an equality by a negative number, the inequality sign must be reversed in order to keep a true statement. So I'm going to highlight my inequality sign and I'm going to reverse it. So here I'm going to have x is now greater than -5. And then that's what I would graph, because we're going to be graphing these two. So we'd have -5, -6, -4. It's greater than, it's not equal to. So we're going to have an open circle, and it's anything that's larger than -5. So it's going to be shading to the right on that. And here, if just to show you why, like, it's not just some arbitrary rule. Let's say we did this. If we have -2x is less than 10, and let's say I hate dealing with negatives, I don't want to divide by a -2. Well, let's not do it. Let's go like this. Let's add the 2x to both sides. And then I'm going to subtract the 10 from both sides. And then think about that. The 2x is going to go away. The 10s are going to go away on this side. And then I'm going to get a -10 is less than 2x. Now I divide both sides by 2. And I'm going to get -5 is less than x. And you might be saying, wait a second, I didn't have to flip the inequality sign for that one. Am I still going to get the right answer? Well, let's write it the same as this. I'm going to move my x to the left. I'm going to move my -5 to the right. And then look, if I read it from right to left, it says x is greater than -5. And so I need to make it so it's the same statement, right? X is greater than -5. It's the same thing. So that's where that kind of arbitrary rule of if you divide by a negative, make sure you flip your sign. That's where it comes in, because if we just added the negative to both sides and moved the constant term over, we are having to flip our sign during that process anyway. So I just wanted to show you the why behind that. All right. Let's do another example here. So here's your first official example. So our first official example is 4p plus 5 is going to be less than 29. So let's use the same process that we would use for an equation. We're going to subtract 5 from both sides. Then we're going to get 4p is less than 24. Now divide both sides by 4. Because we're dividing both sides by a positive 4, we don't need to flip our sign, and we're going to get p is less than 6. And that is our answer. But here we go. We're going to have to do some checks on these as well, just like what we did for equations, and we're also going to graph it. So before I go to the trouble of graphing, I want to check it. Now here's something that we have to do for inequalities. There's actually 2 checks that we have to run. We have to check the critical value, and then we have to check essentially our inequality sign. So we're checking another value. So let's just talk about checking the critical value. So here I'm going to say check critical value, which is our endpoint. So let's check that. So we're going to get 4 times 6 plus 5. Is that less than negative, or is that less than 29? Well, let's find out what happens. 6 times 4, that gives us 24, plus 5, that's going to give us 29. Is that less than 29? No, but we weren't checking our inequality at that point. We were just checking our critical value. When we check our critical value, this side should be equal to this side, and it is. So that means our critical value checked out. So now let me check over here. We're going to check our inequality sign. So check our inequality sign. So here's how we check our inequality sign. Choose any value that's in your solution set. So what that means is any p-value that's less than 6. And what that's telling us is that, like, if we get a true statement, that means our inequality sign is pointing the right direction. If we get a false statement, meaning like at the end of this, we get something that says 8 is less than 6, then that tells us that our inequality sign needs to be flipped, and you would open it up the other way. So let's check our inequality sign. Pick any value that is less than 6. And I think a really easy one is check 0. Check 0, because is 0 less than 6? Yes. So yes, it is. So let's check 0. So we're going to plug in 0, and it's going to be 4 times 0 plus 5 is less than 29. So this goes to 0, and then we get 5 is less than 29. Is that a true statement? Yes. So that means our inequality sign is also correct. So now we are ready to graph. We are going to graph. We're going to put our number line down here. We're going to put the number 6 and 7 and 5. And then we're deciding if it's an open circle or a closed circle. Is our critical value, your question is our critical value included? Is it p is less than or equal to 6? And the answer is no. So it's an open circle, and it's anything that is less than 6. So we are shading to the left on that. So shading to the left. And then we are finally done with that problem. So let's look. I think I'm gonna squeeze in number 2 over here. So number 2, we've got 15 halves, 15 over 2 plus x, which is greater than negative 37 over 4. So 15 over 2 plus x, which is greater than negative 37 over 4. All right, I would like to, you have an option here. You can either get a common denominator of 4 on this guy, or you can eliminate your denominator and multiply them all by 4. I am going to choose to do that. If you would rather get a common denominator and then bring that 15 halves over after you get a common denominator and set your x equal to that value, go for it. I'm going to eliminate my denominator, and I'm going to multiply this by 4 and this by 4 and this by 4. So then what that means is that 4 over 2, so this 4 over 2, this becomes a 1. 4 over 2 would reduce to 2. And then 15 times 2 is going to give me 30. So 30 plus 4x is greater than, these 4s are going to cancel out, is greater than negative 37. Now I'm ready to keep going. I'm going to subtract my 30. I'm going to get 4x is greater than negative 67. And now I am ready to divide both sides by 4. And I've had students ask me, now, wait a second, because there's a negative here, do I need to flip my sign? No, only when you're multiplying or dividing by a negative. So if this 4 right here was negative, then you would flip your sign. But you don't need to flip it if what you're dividing by is positive. So then we're going to have x is greater than negative 67/4. Well, that's not super helpful to graph, right? Negative 67/4. So let's change that into either a decimal or a mixed number. And this is going to end up being, and you're welcome to use your calculator if you want to, we're going to end up getting negative 16 3/4 for this. Or you can write negative 16.75. That's also okay. So let's talk about checking this. I'm eventually going to graph it down here. Let's talk about checking it. And I think I'm going to check my check my critical value right here. So here I'm going to check my critical value. And I've got 15 halves. And I'm adding a negative. What did we have? I'm going to do negative 67/4. And does that, in fact, give me negative 37/4? So is that what it's going to give me? And actually, I think what I'm going to do, just so it's not confusing, when we are checking our critical value, let's go ahead and we're just going to put an equal sign there. Negative 37/4. I think that'll be easier. It'll make better sense. All right, I'm going to get a common denominator. So I'm going to multiply this by 2 and this by 2. So then I'm going to get 30/4 minus 67/4. Does that give me negative 37/4? And 30 minus 67 absolutely gives me negative 37/4. So check. That tells me, again, that this is correct. And then let's check something in our solution set. So look at this. We need to choose any x that is greater than negative 16 3/4. If it is helpful for you to think about it in terms of a graph, so anything that is larger than negative 16 3/4, what's another super easy number that is larger than negative 16 3/4? And it should be like 0. 0 is another good one that's in that solution set that we can check to check the direction of our inequality symbol. So now let's do our check over here of check other value, or you can say check inequality. So by the way, in your notes and in your workbook, we either use the term inequality or other value. Just pick any other value. And we're choosing another value in order to check our inequality. So something that's in our solution set is x equals 0. So I'm going to check x equals 0. And we go back up to our original problem, and we've got 15 halves plus 0. Is that, in fact, going to be greater than negative 37/4? Well, here we've got 15 halves, which is positive. Is that going to be greater than a negative? Absolutely. So that says yes, and that checks that our inequality sign is opening up towards the correct value, because you're checking to see, should it actually be this? Or should it be this? Should it be greater than? So let me tell you something here, because this is a common error. If you get something that's inaccurate at this point, it's like you get this instead. So you got 15 halves. Let's say you got this. 15 halves is less than negative 37/4. If I got that, I would look at that and go, oh, that's false. So I would check my work here first to make sure I didn't make a mistake. And then I would probably go up and check my work here and make sure I didn't make a mistake. And if I didn't make a mistake here, then what that tells me is that in this process over here, at some point in time, I should have flipped my inequality sign, like I divided by a negative at some point, and I forgot to flip it, which would mean at the end, so if you get a false statement here, that means at the end of it, you need to flip your inequality sign on your answer so that you are getting a true statement. And then you can check your answer again and just make sure it's correct. If that's not making sense to you, please reach out to me so we can go over that. All right, let me write it in correctly. Write it, and then what I mean is write it in that blank correctly. So let's go over here. Now we're going to graph. And here we've got negative 16 and 3/4. So what two integer values is that in between? That's in between negative 17 and negative 16. And I'm going to put negative 16 and 3/4 about right here. It's going to be an open circle. I'm going to write negative 16 and 3/4. And we are shading everything that is larger than negative 16 and 3/4, anything that is shaded to the right towards positive infinity. All right. So let's do another one. Number 3. Let's say we've got negative 6p plus 14, and it's going to be less than or equal to negative 58. Negative 6p plus 14, and that's less than or equal to negative 58. All right, here we go. Let's subtract 14. And we're going to get negative 6p, which is less than or equal to 58. So you're doing 58 plus 14, and that should be giving you 72. I'm sorry, that should be negative. Negative 72. Now you are dividing both sides by a negative 6. Math siren should be going off in your brain because we divided both sides by a negative. What do we need to do with our inequality sign? We need to flip it. So we're going to do p is greater than or equal to, and it should be 12. P is greater than or equal to 12. All right, let's check our critical value. And we're going to check our critical value of 12. So p equals 12 is what we're checking. And we're going to do negative 6 times 12 plus 14. And we are checking to see, is that in fact equal to negative 58? Did I do my process right? So negative 6 times 12 should be giving me negative 72. And I'm adding 14 to that. Is that in fact going to equal negative 58? And negative 72 plus a 14 does in fact equal negative 58. So check, my critical value is correct. Now we're going to check our inequality sign or our other value. I'm just going to write OV for other value. This is us checking our inequality sign. So I wanted to do this one too, because so far all we have chosen is 0 because that's been in our solution set. So here are 2 ways you can do this. I like to choose something that's in my solution set. So if I choose something that's in my solution set, I'm picking something that is larger than or equal to 12. So you could do like 12 and a half. You could do 13. You could do 14. I like to choose something ridiculously large because it's easier to do. Or like 100. Like is 100 greater than or equal to 12? Yeah. So I'm going to check p equals 100 because it's greater than or equal to 12. So I'm going to do negative 6 times 100 plus 14. Is that going to be less than or equal to negative 58? And even at this step, I can say, oh, definitely, because we're going to get negative 600 plus 14. And is that going to be less than negative 58? Absolutely, because we're going to get negative 600 and then we add 14 to it. So it's going to be negative 500 something, right? So you're going to say, yeah, that negative is much smaller than negative 58. And therefore that checks your inequality sign and it says true. Now here's another way. So one of my colleagues likes to do this method and they say, okay, let's just do 0 all the time. Let's just plug in 0. Our other value will always be 0. And then you just look to see, okay, if I plug in 0 here, is 0 greater than or equal to 12? No. But what that means is that if you plug in 0, you should get a false statement at the end. And so we get negative 6 times 0. So we are predicting that we will get a false statement if we plug in 0. And so we would end up getting, so negative 6 times 0 is 0. So then we end up getting 14 is less than or equal to negative 58. Is that true? No, that's false, but that's what we predicted, right? Because we knew that when we plugged in 0, we know that 0, if you plug it in up here for your p, is 0 greater than or equal to 12? No. So you kind of have your choice. So your choice is, this is how I'll show you examples. I always pick something that's in my solution set. This is my method. One of my colleagues' methods is to always choose 0, and then you are interpreting whether you, when you check it, whether you should be getting a true statement like we've gotten on our past 2 examples, or a false statement. Your choice on how you would like to do that. Okay, so now we still have to graph. So let me graph this guy. And our answer is 12. So we're going to do 11, 12, 13. It's going to be a closed circle because our endpoint or our critical value is included, and it's anything that's larger than 12. So it's going to be shaded to the right. All right, I'm going to do example number 4. Example number 4, we've got 1/3 times our x plus 3 plus 1/2, and that is greater than -9/2. You guys should pause the video and see if you get the correct answer. What you guys should be getting at the end of this is x is greater than -18. So pause the video and see if you can get that on your own. And if you don't, watch my process and see how you do. All right. This is what I would like to start with. You guys may have chosen a different first step, but this is what I would like to do. I'm going to distribute first, and then I'm going to get 1/3 x, and then I'm distributing here. 1/3 of 3 is 1. So I'm going to write 1 plus 1/2, which is greater than -9/2. Then I'm going to go ahead and combine these two. I've got 1 1/2, which is 1 1/2, and something else. Actually, I'll do that in the next step. So I'm going to do 1/3 x plus 1 1/2 is greater than -9/2. And then 1/3 x, you choose, you can either change this 1 1/2 into an improper fraction, or you can change this -9/2 into a mixed number. I'm going to go ahead and say, I'm going to subtract this -1 1/2. And I'm thinking about how -9/2 is essentially -4 1/2, right? So I've got -4 1/2, and then I'm taking away another 1 1/2. So 4 and 1 is 5. 1/2 and 1/2 is another 1. So it's going to be -6. So then I'm going to have is greater than -6. Now I'm ready to get rid of this 1/3. So I'm going to multiply by its reciprocal. So that goes away. And I'm going to get x is greater than -18 for that. So we're not going to check this one. We're going to save some space on our paper. We are going to graph it though. So we're going to have -18, -19, -17. It's an open circle because it's just greater than, and it's anything that's larger than -18. So we're shading to the right towards positive infinity. All right, let's try. I think I'm going to skip this one. So let's try this next one. So we've got 5/2 plus 7x, which is less than or equal to 4x minus 7/2. All right. This one, you should be getting x is less than or equal to -2. So pause the video, try it, and see how you do on this one. What I am going to choose to do is I'm going to choose to subtract 5/2 from both sides because I see that I have 7/2 with a common denominator. So I'm just going to subtract. I think that'll be pretty easy. And then I'm going to subtract the 4x from both sides. And so then I am left with 3x is less than or equal to negative 12 halves. And negative 12 halves ends up being negative 6. So then I'm going to get 3x is less than or equal to negative 6. And then I'm going to divide both sides by 3. And x is going to be less than or equal to negative 2. We're going to graph. Negative 2, negative 3, negative 1. Because it's less than or equal to, it's going to be a closed circle. Anything that is less than 2, shading to the left. Left is less. Left is less than, or less than or equal to. Let's try another one. So this time we've got 5 times this quantity of 2 times 3 minus x minus 1. And that is going to be less than or equal to 27. All right. This one, you should be getting x is greater than or equal to negative 1/5. X is greater than or equal to negative 1/5 is what you should be getting. So pause the video again, see if you can get that on your own. All right, so let's distribute. Then we've got 5 on the outside. We're going to have 6 minus 2x minus 1. Again, all of these steps that I'm doing, I'm following order of operations. I'm going with the inside set of grouping symbols. I want to clear this multiplication right here. So I'm going to clear my parentheses. And now I'm going to simplify inside my bracket. And so now I've got 5 times this quantity of 6 minus 1 is going to give me 5 minus 2x. So then I'm going to distribute again. And I'm going to get 25 minus 10x is less than or equal to 27. I'm going to divide both sides by 20. I said divide, I meant subtract. Subtract 25 from both sides. And then I've got negative 10x equals 2. Divide both sides by negative 10. And then math siren should be going off in your head because you're dividing both sides by a negative. So flip that inequality. So then we're going to get x is greater than or equal to negative 1/5. Then when we're graphing, it's going to be, so what 2 integer values is it in between? It's going to be in between negative 1 and 0. Negative 1/5 is closer to 0. So I'm going to put it about right here. It's a closed circle because that critical value is included, and it's anything that is larger than negative 1/5. So we're going to be shading to the right. All right, I've got 2 more examples for you. 2 more examples for you. So number 7, we are going to have 5d plus 12 all over negative 3, and that is going to be greater than negative 4. That is going to be greater than negative 4. All right, on this one, you should be getting, if you want to go ahead and try it without me first, go for it. You should be getting d is less than 0. All right, here's one of 2 ways. You can choose to either multiply immediately, both sides by negative 3. It's going to cancel out that negative 3 on the left-hand side, and it's going to flip your inequality sign. Sometimes I have found that that is confusing for some students, and then we end up getting the wrong answer. So what I am going to suggest is that we do what we did on a previous video, and we split it up like this. And so then we get negative 5d over 3 minus 12 over 3, which is greater than negative 4. Sometimes I've had students ask, where did this negative come from? That negative came from this negative 3. And then that's exactly where this negative came from. I have had some students ask me, can I just put a plus here and keep the negative down there on the 3? Absolutely. As long as you're accounting for that negative somewhere in your work, that's totally fine. All right, so now I've got negative 5d over 3. I see that this is going to simplify to negative 4. So I'm going to add that 4 over. And now I'm getting negative 5d over 3 is greater than 0. So I'm still going to keep going to solve to go over my work. So I'm going to multiply both sides by 3 to get rid of my denominator. And I'm going to get negative 5d is greater than 0. Now I'm going to divide both sides by negative 5. Math siren should be going off in your head because you divided both sides by negative. Circle up that inequality. And you're going to get d is less than 0. Because what is 0 divided by negative 5? It is still 0, which is why you get 0. So then we're going to put up here, we have 0, we've got negative 1, we've got positive 1. It should be an open circle, and we are shading to the left. One comment. At this stage, I have had students ask me, Liz, you multiplied by the reciprocal on other ones. Can I just multiply by the reciprocal on this one and multiply it by negative 3/5 and just be done with my process? Yes, you can. If you see it at that point, go for it. You could absolutely multiply here by negative 3/5, and you would multiply this side by negative 3/5. And then at that point, you would flip your inequality. And 0 times negative 3/5 is still 0. So you would end up with d is less than 0. Again, it kind of just depends on what you see mathematically as you're solving your problems. So there's so many ways you guys can approach these. All right, my last one for you guys. We've got 4, and I'm sorry, this is number 8. We've got 4 plus 2x is all over 8, and it's going to be greater than or equal to 3. If you want to try this one on your own, at the end you should be getting x is greater than or equal to 10. If you want to pause the video and try it out. So here I'm going to split it up. Again, if you wanted to multiply immediately both sides by 8, you can totally do that. I'm going to choose to split it up so we don't make any mistakes in here. And it's going to be greater than or equal to 3. And then I am going to choose to still multiply everything by 8 to get rid of my denominators. So then that crosses off, that crosses off. So now I get 4 plus 2x is greater than or equal to 24. I'm going to subtract the 4. Then I get 2x is greater than or equal to 20. Divide both sides by 2. And x is going to be greater than or equal to 10. And then let's do our number line. So we're going to have 10, 11, and 9. Open or close circle should be closed because that critical value is included, and it's anything that is greater than or equal to 10. So we're shading to the right on that one. All right, we are going to apply what we've just learned and do a couple of word problems, and then we are done with this video. So here we go. Number 1, Jamie's clinic will break even for the day if the 15 doctors see at least 135 patients total. There's the inequality part, at least. So we're going to interpret that and say what that means in terms of an inequality here in a second. If Jamie wants each doctor to see the same number of patients, and Jamie wants the clinic to at least break even, there's that at least, how many patients should each doctor see? So first we are asked to define our variable. Well, that's asking you, what are we looking for? What are we even trying to solve for? And we are looking for how many patients should each doctor see. So my variable, I'm just going to do P for patients. And by the way, you're not just going to say P equals patients. That's not specific enough. So we need to say P equals our number of patients. And it's not just number of patients, because that would maybe be total. Having a hard time spelling and talking today. All right. I forgot my N when I was talking. So it's number of patients per doctor. So ENTS per doctor. So number of patients per doctor. So number of patients per doctor, we are saying that's going to be 15P. And then we're going to have 135 on the other side. So I want you to think about this in our inequality. Like this is actually like what's going to happen, how many patients we're going to see. Total patients seen. And this is our goal, right? So this side on the left is like what's actually going to happen. And the right-hand side is representing our goal. Well, then you have to decide which inequality is going to fit in this space right here. Is it going to be greater than or equal to, greater than, less than or equal to? And so you need to think about that. Like, do we want to be less than or equal to our goal, less than our goal, greater than our goal, greater than or equal to our goal? And because it says at the very minimum, we need at least 135 patients, which means at the bare minimum, we need to hit 135 or more. You processing that says we need it to be that one. So it's going to be greater than or equal to. So there's our inequality. Here's you defining your variable. Here's your inequality. Now we're going to, show our work. So you're going to copy your inequality down here. 15p is greater than or equal to 135. Now you are going to divide both sides by 15. Punch that into your calculator. And you should end up with p is greater than or equal to 9. P is greater than or equal to 9. What does that mean? How do we interpret our answer? So, and that's what we're going to write down here is interpreting our answer. Means that every doctor needs to see at least 9 patients. And that's what we're going to end up writing down there. So justification for rounding if needed. This is kind of like a not applicable. So NA, because there was no rounding needed. So you guys are welcome to write NA, not applicable, or you can write no rounding needed. We didn't have to round. It came to an integer value. We're going to have to round on the next one though. So then our solution. So if we had to round, you would kind of show that work here, and then you would actually tell me, well, what is your rounded answer? So what is your solution for this problem? Well, ours is going to be the same because we didn't have to round. So it's going to be the exact same. Then we're going to graph. So this is going to be 8, 9, and 10. And then we're interpreting this. So it's going to be a closed circle here, and we're shading to the right. So they need to see at least 9 patients. So for our statement, we're going to write out exactly what we've just been talking about. Each doctor needs to see at least 9 patients per day in order to break even. So just write out your statement there, kind of interpreting your answer. All right, let's look at the next one. Rhonda is giving candies to 3 different children. So we've got three kids. She has 19 candies and she wants to make sure that each child gets an equal amount. And it's not stated in the problem, but the candies that we were thinking about are like the candies that you're not going to be able to like easily break into pieces or break into halves or quarters or anything like that. So how many candies, like how many whole candies can she give to each child? So I'm going to put this in here so it's very clear. How many whole candies can she give to each child? So first, define your variable. What are we looking for? What is our unknown? And it's the number of candies per child. So I'm going to say C for candies. So C equals number of candies per child. So then we've got to write up on our inequality. Well, what's our constraint? What's the goal? How many candies do we have total? We've got 19 of them. How many kids do we have? We've got 3. And then we are multiplying that by the number of candies that we're trying to figure out. How many candies can I give to each child? So then you got to figure out what's going to go here. Are we going to give less than? So here's our choices again. We've got greater than or equal to, less than or equal to, less than. And so you want to think about like, okay, here are 19 candies. Can I go above? Like you want to think, can I go below that or can I go above the number of candies? We only have 19 candies. We can't go above it. So it's not going to be this one or that one. So now you need to decide, can it be exactly 19 candies or does it need to be less than 19 candies? And you can go back and read, or you can think about, well, is it okay to give away all my candies? Yeah, it's totally fine to give away all your candies, which means it can be less than or equal to. So it can be equal to 19. All right, there's our inequality. Let's copy our inequality down here. 3c is less than or equal to 19, and let's show our work. Divide both sides by 3, and c is less than or equal to, oh, that's not going to go into it evenly. How many times is it going to go into it? 6 times. 6 times 3 is 18, with 1 left over. So it's going to be 6 1/3 candies, but we already talked about it has to be whole candies. So what do we need to do instead? What that means, and think about your variable here, the number of candies has to be less than or equal to 6 1/3. So your choices are, can it be 6 candies or can it be 7 candies? Which one of those is less than or equal to 6 1/3? And it's going to be 6. So it's going to be 6 is less than or equal to, or C is less than or equal to 6. So there's our solution. That's what we're going to put here. C is less than or equal to 6. Our justification for rounding, we are going to round down to nearest integer. Because it needs to be a whole piece of candy. And we're rounding down because of the inequality. So that's the other reason. All right, so let's put it on our graph. We've got 5, 6, 7. We are going to be filling it in as a closed-in circle, and then we are shading to the left because it's anything that is less than or equal to 6. Now we're writing a statement. So she can give at most 6 candies to each child. And there's your statement. And that is it for this video. Thanks for tuning in.